Understanding the dynamic nature of atomic nuclei. The atomic nucleus is one of the most mysterious and complex parts of the universe's building blocks, and in 1975, H. N. Bohr, Ben Roy Mottleson, and James Rainwater were awarded the Nobel Prize in Physics for solving a key puzzle about the inner workings of atomic nuclei. Let's start with a question. What's inside the nucleus of an atom? Protons and neutrons, right? But here's the thing. How do these particles arrange themselves? Early theories suggested that the nucleus was perfectly spherical, like a tiny solid ball. But this idea didn't quite fit all the experimental data physicists were seeing. James Rainwater, an American physicist, had a bold idea. He proposed that the nucleus wasn't always spherical. Instead, it could have a distorted shape, more like a squashed football or a stretched-out rugby ball. This distortion, he theorized, happened because of the complex interactions between protons and neutrons inside the nucleus. But a theory is just a theory until you test it, right? That's where H. Bohr and Ben Roy Mottleson came in. Working together in Denmark, Bohr and Mottleson performed groundbreaking experiments to show that Rainwater's theory was correct. They discovered that certain atomic nuclei could change their shape depending on how they were spinning or vibrating. Here's the kicker. This wasn't just a random quirk of nature. These distorted shapes explained how nuclei can have different energy levels and how those energy levels affect the stability of atoms. It also helped physicists understand phenomena like nuclear fission, the process that powers nuclear reactors and atomic bombs. Their work combined theory and experiment in a way that changed the way we see the nucleus. It showed that atomic nuclei aren't rigid, they're dynamic, living systems, constantly changing and adapting. This discovery became one of the cornerstones of nuclear physics and is still used today in everything from understanding radioactive decay to building safer nuclear reactors. So the next time you think about the tiny nucleus at the heart of every atom, remember this. It's not just a simple ball of particles. It's a dynamic, ever-changing system that holds the secrets to some of the most powerful forces in the universe. What other discoveries in nuclear physics fascinate you? Like and follow for more stories about the science shaping our world.